Hi everybody, welcome to my workbench on part 3 of the old school transmitter, CW transmitter. In front of you can see the layout from the front of the transmitter. So I worked things out already. So this will be stick on that piece of cardboard, stuck on there. Yeah, and we fit it on there. So I was going to show you some more of the transmitter itself. So anyway, I will stop for a moment and reposition the camera, and then we'll talk further. Okay, there we are, guys. As you can see, I put the frequency counter in. So the knobs are missing now. And yes, I showed you previously what I'm going to do. Anyway, that's what I'm going to do next. Put that on there. Just work this out, stick it down, seal it, and stick it on, and then put everything. Put the meter back on, and put that counter in again, and then put all the knobs on again. So that's the next step to do. The following step is, I'll show you. The following step I'm going to do is to connect this switch onto the coil, and then we can, with the grid dipper, we can see how this works. If you can see the coil come into resonance on the right frequency, and so on and so on. So the next step then is to populate this switch with the coils necessary to get all the bands. I decided to go on the mid-wave. I think that will work, at least in the latter part of the mid-wave, say from 1400, I believe, 1400 kilohertz to 1600 is possible. Then we have the 160 meters we're going to use, and the 80 meters, the 40 meters, and the 20 meters. And the band coverage will be complete, so it goes from the lowest frequency to the highest frequency. So and if I'm right, it's overlapping, so we have to see how that works. Anyway, I believe this coil is big enough to get a resonance on 1400 kilohertz with a 550 picofarad capacitor. What is in there? Oh yes, I forgot to mention this. I had a previous another capacitor in there with an porcelain axle. And unfortunately I made a mistake and I broke the axle, so I had to chuck him out. So I found myself a new capacitor, and that will be suitable, and I put that one in. I can show you it is that as you see the first video, you will notice the difference. So I'll show you once more. So there he is, 500 picofarads capacitor. And there we go. As you can see also on the back the frequency counter I put in. So I had to make a new one. I had two already populated, but because if I put the digits too low, I couldn't fit it in there. So I had to remake one, and with the proper distance, so that you can put the digits in there. So far so good, chaps. I will continue with my efforts, and I will come back to you. All right. Hi everybody, I'm back again. Well, chaps, I told you I would use the mid-wave. You can forget that. I have checked all the connections. If I use the normal coil with total capacitance, I can only use, excuse me, 160 meter bands, as on this connection here. So this is, say, the connection from the capacitor, and this is the connection from the capacitor. Then we have on this self-inductance plus the capacitance, you have the ability to use 160 meters. That will work. Excuse me, I have a bit of indigestion. So then the next part for connection is the 80 meters. That will work as well. That will even overlap this a little bit. The next connection for the 40 meters is up here. That will work as well properly. And then we have the 40 meters, the 20 meters. So we have this connection here. And I'll show you the stance of the capacitor. There. You see how wide open he is? Well, it works. I can show you. I don't know if you can see it. I can show you. Anyway, you have to believe me on my word. This capacitor will work at 40 meters. It's now the stands at 14350. So I can see how far it will go up. So hold on. I have here the meter, 14350. I put them up now to as maximum it goes, say nearly 80 megahertz. I will dip them. I will see if it will work. If that will work. No, I'll even get there. I won't get there. So I won't get to 18. I will try 15.3. Yeah, I will try to dip that. He reacts to that on the maximum capacitance. On the minimum capacitance. So he's totally open. He goes to 15.363. Anyway, chaps, I don't have much confidence in this connection on 20 meters. This coil is very small and I have little capacitance left. So what I will do, I will put it on there, but I don't believe it will work properly. I have my doubts. So having said that, I will put that in anyway. So I checked them. So I have 160 meters, 80 meters, 40 meters and 20 meters. Now, as I said, I have my doubts if it will work properly. So anyway, so leave it at that. So you can see how far this is apart. 160, 80, 40 meters, and then you get 20 meters. Now you can go, perhaps even go even further down, but I can consider that. So yeah, I will make that on the practical side of it. I'll check that in real time if that is tunable. I can go one further down. There's the second winding, so I could try that. I don't believe it will do much good. Anyway, I will try it, leave it at that. If it doesn't work, it doesn't work. That's tough luck. You can't have it all. And the other part is if I put another coil back here for the antenna, there could be some lowering of frequency. So because of the the load I will put on there, could draw the frequency a bit down, but I don't believe that. Anyway, you can see, guys, we have to make compromises. 160, 80, 40 and 20 meters. 20 meters is a bit in the air, so I will put on the bars and go from there. So that's the only thing I can say. And then hopefully it will work out. It will work out for 40 to 80 and 160, I'm sure of that. But for the 20, I don't know sure. I don't know that for sure. Anyway, guys, so far so good. I will conclude this part. Yeah, I keep the videos as small as possible. So if I start to fit the front and have done the population of that, I will start off making progress with the oscillator, and then we'll come back to you and we have something more to show than we have now, so it's a bit early to say what's going on. Anyway guys, if you like the video, give me a thumbs up, and I'll see you in the next part.